What's up, guys? I just wanted to show you a video that I made the other day. Not the other day, long time ago when I first started doing this electrical stuff. Trying to find where's my dang. Let's see here. It's when I first started getting into electrical, and I built the Gerard Morin pump motor generator thing. He called it the Voodoo Machine. And it's just a motor that drives a little generator. Magnetic generator that puts out 240 volts open circuit, 120 volts under load, or 150 volts under load, depending on the type of load, how much of a load. It'll even, I've seen it under full load drop all the way down to like 30 volts, but that was within overload. It'll maintain 120 volts up to about 5 amps. And so I'm taking that 120 volts and I'm running it into a high voltage transformer, an ignition transformer that puts out 6,000 to 20,000 volts. And I'll just play you the video real quick because it's only a couple minutes long. And you can see this thing.
Alright, so this is my system. I've got a brushless drill motor right here connected to this battery, and
I'm in a bad location for service, so it may freeze up every now and then. I'm trying to let it load up a little bit, but yeah, I'm running off this 18 volt battery, which the knife switch controls.
This knife switch. The output of my generator goes into this knife switch. The output of my generator goes into this transformer, ignition transformer for furnace. The blue wire goes into the capacitor, into the high pressure sodium, through the high pressure sodium, out through this black wire, and into this side of the spark gap. Then this wire coming off of the same side goes to one side of the little bulb. Other end connected to nothing. The other black wire coming out of the spark gap goes to this little incandescent bulb right here, and it will manifest the plasma. Other end of the bulb connected to nothing. Other side of the spark gap, one wire. We'll start with the green wire. Green wire goes to this bolt, to this line, this wire, this tiny little wire. It's running on that to that bulb, that bolt, going to one end of that long bulb. This end, you can't really see it, but this end is connected to nothing. Pull it out of there so you can see it. It's connected to nothing. Okay.
So what that means is this high voltage is building pressure in these circuits because they're open-ended. They're open circuits.
And then this side goes through the little high pressure sodium into the bottom side of this first coil,
So everything is run in series until it reaches an end, you'll see.
Other side of that coil goes into one side of the mini fluorescent. Other side comes out and into one side of this second
Man, I'm freezing
coil.
out.
White wire comes out of that coil and into a bridge rectifier. Okay, just one wire. Negative to one side of the LED, positive to the other side of the rectifier. Okay. So the only other thing I have to show is back to here. This side of the transformer just goes to ground. Ground rod I got down there. Okay, that's it. Just goes to ground.
So what I discovered from running this machine, this electrical device, is that the big high pressure sodium bulb there standing upright that's connected to the transformer, because the other end is open and because the other end of the transformer is connected to ground, when the bulb arcs, it sends out, every time the bulb arcs, because it's a frequency, every time it arcs, it's sending waves out through the air. And those waves are seeking the ground. It's sending out electrical waves into the air. And that field is connecting itself to ground, even at the slightest potential, without physically being connected. But it wants a ground connect. It's seeking the ground. It wants a ground. So when I connect myself to the system, it actually increases the power of the system because it's connected to ground. It's pretty interesting stuff. And you'll notice that as I'm running this thing, when I'm coming up in RPMs, every time I hit a different frequency, the white line inside the bulb changes. It changes. You can see different nodal points in it, and I eventually stop it to where there's only one nodal point, and it's right in the middle of the bulb, and that's where I stop it. Stop increasing RPMs and start just playing with it and doing tests and taking readings and stuff. And that's when it seems to be its most powerful as well. So just play this thing here. Sorry about the beeping in the back.
Alright, so now that we got the lights dimmed down, I'm going to throw the switch, and I'm going to increase my speed. I'm going to start out really slow and watch as to how this reacts to slow RPMs. First, my little light's going to come on. There we go. And I'm going to run this thing real slow.
I hate it that YouTube has monetized my channel without my consent. They just play ads on all my stuff, even though I'm not eligible for monetization. Anyways, so I'm going to run this thing, and I'm going to take some amp readings with an amp meter. And you'll notice that it will pick up, it'll pick up just in the air without being around a wire. And because it's picking up that signal, it's picking it up. And you can take measurements right out of the air with your meters, with a voltmeter or an amp meter. See how that bulb? See how the high pressure sodium, it's got a wiggly line in the middle? It's wiggling around, and now it's more along the edge. But that's like a full wave. That's running at full wave. I think it'd be full wave. That frequency is making a full wave inside that tube. So that's 12.5 amps, 6 amps, 7 amps, 8 amps. You know, supposedly coming off that battery wire. But since all the wires are antennas, and since the electricity is going out into the air, you're just picking up what's around that wire. There's 22 amps on the ground wire. You know? Up to like 30 amps, 30, 40 amps. I can't remember what the highest was that I read on there, but it was like 40, 50 amps. I'm thinking, what the heck? 40, 50 amps? That's crazy. Only getting 13 off the battery. You know? This wire here, it's wanting to read 40, 50 amps, 60 amps. You know, that's a lot of amps. 75 amps, 80 amps almost, 79. And then I check this wire here. And this wire kind of freaks me out because there's 165 amps that I'm reading. 170, 180 amps, 190, 200 amps, 215, 216, 216 amps on that line is what that meter is picking up. Sometimes it don't read the screen, but it was like 130 amps right there on that line. Going into the capacitor straight from the transformer. And I'm thinking, what in the world? How am I getting so much current? How am I picking up so much current? And you can't tell, but I'm on the 400 to 600 amp scale. And if I switch it down to the 30 amp scale, it gives me a totally different reading. And it's a lot lower. It's a totally different reading. So the scales, depending on how they're calculating their scales, it's showing me way more power than it's putting out. Because you got to remember, that's 6 to 20,000 volts on that line. Well, if you do amps times volts, you know, let's just say it's 6,000 volts on that line times 200 amps. That's a lot. That's like 12 kilowatts. Being generated from an 18-volt battery as the prime mover. Because all I'm doing is I'm using a mechanical conversion method to make high voltage. And one of the things that I discovered is that you can do away with that motor generator altogether and hook your high voltage transformer up to a audio amplifier. And that amplifier will drive that transformer at whatever frequency you set it to. Because you can put an input on your audio with your audio jack, you run that to a signal generator, and then you can put whatever signal you want, whatever frequency you want into that transformer, and it'll output whatever frequency you dial in. And it's pretty cool. It's pretty cool. But that would be a solid state method of producing this same wireless energy. And out of all my experiments, this wireless energy is virtually harmless. It's cold. It's when you touch a pickup antenna, you don't get burned. The electricity jumps over to you, and it might startle you, but it doesn't hurt you at all when it flows through your body. Because it's a different type of energy. It's a radiant energy. It's RF. It's not AC or DC. It's RF. So, anyways,
what could you do with
peace
a
for now.
3D printer?